Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to see how to use background subtraction method in OpenCV. So first of all, what is background subtraction? So background subtraction is common and widely used technique for generating the foreground mask, which is also known as the binary image containing the pixels belonging to the moving object of a scene when these images are captured using a static camera. And as the name suggests, background subtraction calculates the foreground mask, performing the subtraction between the current frame and the background model containing the static part of the scene. So for example, the background subtraction method can be used in the case of visitor counter, where you have a static camera capturing the number of visitors entering or leaving the room, or you have a traffic camera which wants to count the various telematic data from the moving car or moving car data which is captured by that traffic camera. Now there are several algorithms which were introduced for the purpose of this background subtraction, and OpenCV has implemented few of them, which we are going to see one by one. So as you can see here, I have this example, which is a very simple example of just taking a video, and then we are extracting each and every frame of that video and showing it into a window. So using IamShow method, I'm just showing each and every frame of that video. So this you already know from the previous videos, how to capture the video frames from a video file or the live camera. So when I run this code, you will see that there are few persons which are moving here, and we want to detect all those moving persons which are moving in the image. So for that, we are going to use a few methods which are available in OpenCV. So let's first write some code, and I will explain you what this code is going to do. So I'm going to define a variable after this line of code, and I'm going to define a variable named FGBG for foreground background, and then I'm going to just call cv.bgsegm. So bgsegm, and then I'm going to call a method called create background subtraction MOG method. So this create background subtraction MOG method is a Gaussian mixture based background and foreground segmentation algorithm. So using this line, what we are doing is we are just creating a background object of the function using this method create background subtraction MOG. Now this method has some optional parameters like history, number of Gaussian mixtures, and threshold, but all of them are set by default, so you don't need to set anything specifically unless you want to change some of the optional parameters. So I'm going to leave everything as default, and I'm not going to give any argument here for this method. And then after I captured each and every frame inside this while loop, what I'm going to do is I'm going to create a new variable called fgmask for foreground mask. So I'm going to just write fgmask is equal to, and for getting the foreground mask, we are going to just call a method called apply on this fgbg or the background subtractor image. So we are going to just take fgbg, and then we are going to call a method called apply here, and it takes one argument, which is the frame which we are capturing. Okay, so we have applied this method, and then we are just getting the foreground mask using the apply method on this background subtractor variable. And that's it. So this is your foreground mask. So when I just use one more I'm show window, and this is for the FG frame, let's say, so FG mask frame, let's say. Okay, so FG mask frame, and we are going to just pass this argument here. So let's see what result we get after we apply create background subtractor MOG method. So you can see this normal image here, and also you will see these moving persons in the foreground mask, right? So you have subtracted the background from the foreground, and you can easily detect the moving persons here inside this image using this mask. You will also observe that there is a very little noise, not much, when you use this kind of subtraction using create background subtractor MOG method. There is one more method which is called background subtractor MOG2, which is also Gaussian mixture based background and foreground segmentation algorithm. So let's use that method also. So this method is directly available under CV2. So you just need to write cv.create background subtractor MOG2. Okay, and everything will remain the same. So it's going to return you the background subtractor variable, which you can use with this apply method to get the foreground mask. Okay, so let's see how this method performs. So you can see the result, which is quite different from the first method which we have used. So in the previous case, we have to create the background subtractor object, and here in this method you have an option of detecting the shadows. So there is an optional parameter which you can give into this method, which is this create background subtractor MOG2, which is called detect shadows. So by default this detect shadows is true. That's why you see the shadows there. If you just write detect shadows is equal to false, then it's not going to detect the shadows. So I'm going to just run the code once again, and you can see now shadows are less visible, right? So let's run the default case once again. So let's say we just write true here, and you will see the shadows in the gray color, right? So these shadows in the gray color, and when we just make it false, so detect shadows false, you will not see that gray color. Okay, so shadows are displayed in the gray color. So if you don't see any gray color, then shadows are not detected. This is a noise which is detected, but not the shadow. Okay, so this is the difference between the first background subtractor method and the background subtractor MOG2 method. There is one more method which is called the background subtractor GMG. So this algorithm which we are going to use, so let's use this method first of all, which is called background subtractor GMG, which is available under cv.bg segment as the first method. So just write bgsegm dot create background subtractor GMG method. So this create background subtractor GMG method algorithm combines statistical background image estimation and pre-pixel Bayesian segmentation. Let's see how this method performs when we just use this GMG method. And when you will see here, there is nothing on this foreground mask frame. So to get the better result, you need to apply morphological opening to the result to remove the noises. So we are going to do just that. So I'm going to just overwrite this FG mask frame using a method called cv.morphological morphology X. This also we have seen in the previous videos, right? So the first parameter here will be FG mask parameter. The second parameter here will be the op. So cv2 dot morph open. We are going to use the morph open method. And then the third parameter will be the kernel. So we need to define the kernel also. So for defining the kernel, let's define the kernel outside this while loop. So I'm going to just write kernel, which takes few arguments. First is the shape. So we are going to say we want the morph eclipse shape. So I'm going to just write morph eclipse. And then the kernel size will be, let's say, 3,3. Okay, so we are going to apply this kernel using this morphology X method. And when we are going to run this code, you can see these kind of results, which are not as good as you have seen in the first method. Now let me show you the last background subtraction method, which is called the background subtractor KNN method. So this method is available under CV2 directly. So we are going to just comment this kernel code, because for this method we don't need to define any kernel. So we can just write CV dot create background subtractor, and then at last you just need to write KNN in capital. Okay, and it also takes few optional parameters like history and other parameters, but these are optional parameters. So for now we are not going to set any parameter, and let's see the result which we get using this KNN method. So I'm going to run this code, and you can see this KNN method result. It also shows the shadows in the form of gray pixels. So whatever gray pixels you see here in this image are the shadows. In this method also there is an optional parameter which is called detect shadows, which is set by default to true. So when you make it false, the shadows will not be detected. So you can see no gray pixels are visible now. When you make it true, then the gray pixels will be visible, and those gray pixels indicates the shadows, right? So these are the few methods which you can use for the background subtraction in OpenCV. I hope you've enjoyed this video, and I will see you in the next video.